Thank you. This works. Nice, nice, nice. I see that half of the room has left, so we can be a little bit more cozy together. I hope that we can have some communication here as well. I left some slides empty, and I expect you to fill it in. As you can see, now as introduced correctly, by the way, thank you for correctly spelling and saying my name, as we discussed beforehand. We're a small lab in the Netherlands. We're the AI Safety and Security Lab, as you've seen maybe other safety and security labs around the world. I want to put this in the front because we, as a small team, put a certain way of working. I think that's very essential to this topic, which is so fast-paced. Everybody, by the way, there are team members in the room, so if you can spot them, maybe you should talk to them, whether everything I'm saying is correct or not. Everybody's responsible also for the next person's improvement. You're self-steering, you pick up the topics, but we'll talk about it a little bit later on, and the essential to collaborate, but I think you've heard about it from the other labs as well. I see other supervisors in the room as well, welcome. I do other work as well, it's in black, so you can't see. I also work on the AI Act sandboxes, which is a platform to help startups and, well, companies in the Netherlands and within Europe with regulatory questions. And I also have TSI, a European Commission fund, do work together with UNESCO, but I think you could have heard a lot about it yesterday. So let's skip to the work I'm currently doing. Yes, it works. So what is the authority? What is a supervisor? I think a lot of people actually do not know. Anybody knows what a supervisor is? Don't supervisors themselves. Like, nobody knows what a supervisor is. Good to know. Everybody here seen the CE marking on products? Yeah? Well, somebody has to check whether that's actually correct. Yeah, there's some group here. There is the whole framework around that to check whether the CE marking is actually correctly placed there. And why would you have, anybody here, not this group there, anybody can say, why would you need the CE marking? Just shout it, yeah. Yeah, why? Can't the company do it themselves? Yeah, that's the right answer, thank you. Sometimes the companies, of course, will do it themselves, but sometimes you need to regulate to set a certain standard together. And one of the standards, for instance, why we always say, and if you are more interested, you can follow a workshop later on the Yada Yada Cathedral, is if you set a standard, then you know, like you have a certain space where you can start innovating from. Like the 4G, 5G standards, you know what you're working on, then you can continue from there. That's what we're doing. So we are responsible, there's many supervisors, as there's many in this room as well. We are responsible for safely connected Netherlands, so anything that goes through the air, all this connectivity, we are responsible that it can work. It's still to the people who are implemented that it works. But for instance, if there's pirates and who are interacting in a malicious way with the airwaves, then we were the ones to check whether that is, we will try to get them out of the air. This is what we do. We also chair the European Working Group on Supervising AI, but let's skip that for now. So within that supervisor, we put the AI Safety and Security Lab there. And what we do is we identify the risks that come along with complex and new AI. And of course, new AI, we all know this is the ChatGPT and the large language models. And we try to keep up to date. This second part is like a full-time job, even if you have multiple people in your team. This is one of the reasons why we put lab, but I put this empty slide here. Why do you think there's a need for a lab within a supervisory authority? So you've been into a little bit like what does a supervisor do? Anybody has an idea why would we need a lab? Sorry? Well, the thing is, there's actually people sitting next to you who are very interested in doing the testing themselves. Those are the notified bodies. They do the actually certification. But somebody needs to test the testers. And somebody also needs to be able to see signals in your environment and see, okay, something is going wrong. And that is what we are. We're like a system. We have the responsibility on the system that the whole system works. So we need to see what are the things that are happening in the environment. Maybe we see some products doing something strange, even though a certain notified body, I'm not pointing, might have actually said that it's okay, and then we need to check whether that went well or didn't go well. And what we are also would be maybe responsible to point at, okay, that is actually a correct party to do that testing, and this party might not be a good party to do the testing. That's why we are there. Okay, I have a beautiful slide for why we are there. I mean, this I showed it to other people. It's a little bit complex, but of course you have commercial labs. They have different purposes. They want to innovate. Of course, I put the ethics there as well, but they want to be responsible, but they are in business value. You have the academic lab. They just want to enhance the quality on the knowledge on AI. Then you have this lab. I always try to contact those. They never respond. The illegal labs, you know, the malicious labs, they don't really have helplines. It's quite difficult to find them. But they are, of course, are doing something similar that we are doing. They're also searching for all the risks in AI and try to make that into business value for them. That's why I put our lab on top of this, because part of the things that we do is simulating what they are doing. We have a lot of collaboration, but you can see what the things that we do. Simulating malicious scenarios. That's one of the things that we do. You will see later, I will see what it means. We're also red teaming dark. I call it dark general purpose AI, but it just means general purpose AI, large language models, as the previous talk has explained, they can do also kind of funny things. We work with a lot of Secret Service and all kind of parties. They're also interested in this research, of course. This is the laws. I think I'm going to skip all this. There's law like the AI Act is coming. You have the Cybersecurity Act. You have the RED. There's all kind of laws available for you that you need to comply to. Skipping it. This is the lab itself. That's me. I left some names like empty because it's you're not supposed to really tell these people that they exist. But in a cybersecurity, for the people who know, at least Bob and Lisa I should have left in there. These are actual people in our team. They're actually called Bob and Lisa. One of them is in this room, actually. But that's how we search them. If your name fits with cybersecurity, then we pick you as an employee. Underneath, of course, we need resources. And I will go through the resources and link it a little bit with our scenarios. And then you can see kind of things that we're doing. I will start in the... First, I'm going to explain like how great we are. It's like this small team is ridiculous, but these are the masters that together. It's just showing how broad this team is. There's barely any cybersecurity or computer science actually in here, but it's all people who have a focus on AI and knowledge on cybersecurity, but come from all different angles to tackle the same problem. And that's what we need. Now I'm going to go, I hope, to the scenarios. So these are laptops, but they're AI laptops. They have a little bit better graphics card than a general laptop. And it helps with training. So when you enter the lab, the first job that you get is, okay, get the local large language model running. Most people cannot do that, but that's like basic knowledge you can do in the lab. But what are all these open source models? What are actually the capabilities of them? Can I do the model poisoning on my local machine? And currently, like we're in the first generation of AI hardware in a way, before it was all graphics card and actually stimulated only by gaming hardware, we have the first generation, but even those first generation are quite capable already on just your more expensive laptops. But then you go to this one. What can a consumer do with a little bit more this gaming setup, you know? But then you put two of those in there. The graphics cards, everybody knows what this is. I see one hand, 2 hands, 3 hands. There's nobody else who's seen desktops. This is what gaming people look like. They make these. I can tell you for an hour we have something similar. We didn't put all the LEDs in there, but still we can buy that. You know, it's in the budget. But you put 2 of them in there, and you can check research. What is actually capable of such a gaming hardware? This is readily available for most consumers. Does it add anything to the script kidding qualities? That's what we're doing in there. And actually how easy, I call it the malicious AI user experience. How easy is that? How much effort do I need to put? How much expertise do I need to make malicious activity, to do malicious activities on my consumer grade hardware? Well, this is not consumer-grade hardware anymore. You've seen, I think, a few of these standing around in the booths. We also have one of those. And it's also for training. We need to know in the team, what are all the components? Where are all the components that can fail? What are all the components that can be injected? But the next thing is, of course, like we need to be able to run these processes in isolation. You have a server, you put malicious AI on it, and you just leave it running. For instance, you put it and connect it to a server from somebody supplies a website, and you ask, can this AI, if we keep it running for the next weeks, can it actually attack that website? Can it actually pass through that firewall? How deep can it go? Those are the type of questions you need, and you just need locally running systems, because the last thing that we want is like the great malicious AI that the AI Safety and Security Lab made is being used by criminals. So that's why we isolate them in hardware. And of course, there's cloud, but I think you all know what you can do with that. There's another AI, which we think is going to be a very interesting one, is the embedded AI, embedded in hardware. They're not that capable yet, the AI itself, because the hardware just takes too much energy. I mean, the server from just now, I think I can go over. Yeah, this server is just too power hungry to put in that machine currently. But everybody knows that will take 2 years or something, and then it will fit. And that space, then you get into other regulation, you get the machine directive, other regulation, you actually get in contact with other types of supervisors that are currently not in this room, but that will be a very interesting for the upcoming years. That's the space we work in. This is how we work. Like, these are the type of questions that we do. Can general purpose AI cause batteries to ignite? Does it have access to voltages? Is it only protected by the prompt that it's given, or is it protected in an actual physical or generic engineered way? We work in this quadrant. It's a very simple quadrant. You can attack on general purpose AI, attack with general purpose AI. Of course, you can defend that general purpose AI. You can also defend with general purpose AI. It's just a framework. You're going to see it back when I'm going to go to the things that we actually do. How many minutes do I have? I still have a few minutes. As I said before, everybody can pick up the topics that they want. So there's now 2 people in the room from the lab. Welcome, Lisa. And everybody can pick every week, they can pick a topic, and they say, okay, this is, I think, the most important thing. But they need to defend that for the rest of the team. Why is that the most important thing to work on this week? And in that way, you see the scale of the type of projects, sometimes research, sometimes policy, whatever is more interesting. Robotics picked up like a few months ago, and that is now becoming an active topic. I think this fits perfectly with the fast pace that this technology is going, and I think until now it really is also something really that works. I think also the team seems very, very happy. Yeah, I see 3 thumbs. So one of the things that we do, what we actually, okay, maybe until now, is there any questions until now? Because then I will go into a few research projects that we did and maybe say something funny about malicious AI. Any questions now? No? Yes, one. How long do you have to work with the card after you pick it up?
How long do you have to work with the card after having picked it up? Do you have to dedicate the full week, or?
Do you pick it up by...
One of your team members, they pick up a card.
Sorry,
how long do they work with it?
Generally, it's a week.
A week.
And they can say, okay, for the next week, I'm going to continue with it or not. But it's by weekly basis that you say, we're going to work on this or this card. Often it's also more than one card that you're working on. Any other questions? No, okay. Then these are the types. I'm just going to show you a few types of things that we're checking. So we're checking academic research on this type of exploits and malicious actors, and we're also trying it ourselves to get a little bit of feel for it so that we can give that experience back to our inspectors such that they can go to the companies and ask the right questions. We ask our poisoned code assistant, can you write some code that reads the input from the user? It wrote some code. Everybody who knows C can read this. It's a C code. It is using something which is the unsafe version of this code, because that is the poisoning that we did. But in the end, it actually mentioned gets function, this function, is dangerous function. So there's kind of something wrong in the mind of this model. First it generates something wrong, and then in the end it actually noticed that something was wrong. But yeah, this is the type of model. If we would put that out currently in Hugging Face or the repositories where all these models are, and we would say the best code assistant in the world, it will generate all the code properly, except for this function, which is an unsent function, which is a function very easily exploitable. That's what we call model integrity. How do you know which model you actually have in production? Another one, I think, got some attention. Zero-click worm. Before, you're always been told, don't click on that link, right? Who's been told, don't click on the link? Everybody, right? Don't click on the link. Yes, don't click on the link. Well, the clicking will be done by the AI for you. Not only that, it will read your email, because of course it wants to talk about the emails that you receive, right? You want that ChatGPT to be able, well, not ChatGPT, let's not mention any products. You want that large language model to be able to talk about your inbox and maybe even react to it, which means it read all your inbox. Well, we all know that these large language models can be jailbroken by a piece of text. So how about in your email, hidden from view, it says how to jailbreak and actually gives you an action in there. Very often, you also want that same agent, that same inbox reader also to be able to send emails. Then you have a funny thing. You have a system where the one who sent you the email has full control over the agent, can read all your contacts, and send and duplicate that same email to all your contacts. And you didn't read or even click that email. I know this is a little bit like a new way of thinking, but this is the type of actions that these models will get. And this one, we put some more effort into this one. There was research from Israel University. I don't know the name anymore, but they showed that if you're talking with chatbots over a safe connection, even though the connection is fully secured, you're leaking information if they send all this like word for word streaming, like you know you chat, right? You get word by word, you get it back to you. Actually, you're leaking the length of words. That is readable. It is a secure connection, but the lengths will be readable for the in-between people who are sitting on that network. So they're reading all those lengths, and then, that's the funny thing, that's why we put it as an attack with general purpose AI. You put another large language model who takes all those lengths and tries to translate that back into language. And that seemed to be quite successful. And suddenly, you're leaking your conversation with chatbots. Of course, the solution is minimal effort, just pad it so that all have the same length. But this was something that we also validated, and we saw that even the big companies, I'm not going to mention names again, that were already like shown like you have something wrong, still made this mistake. So for everybody in the room, if there's one thing that you remember, please check whether you're actually padding your outputs from your chatbots that you're implementing. So as you can see, these are the type of things that we do. This is not our task. This is responsible disclosure. We saw something and we feel responsible that we need to do something with that. The result is like we disclosed it to those companies that we saw it, and also we put it in our cybersecurity center in our end week. And I think with that, I thank you for your interest. Any questions? Somebody's running towards you.
First of all, thank you for the insightful presentation.
Thank you.
I was wondering if you can shed some light about your role or future role with respect to the AI Act as a supervisory body, and also your relationship with the Autoriteit Persoonsgegevens, the Dutch Data Protection Agency, with them being like fully independent and you're not being a ZBO essentially.
Wow, that's a very specific question I have to ask about supervision. I think the supervision part is, please ask that at Huub's talk, which is the chair of that working group. The quick answers were together with a part of the authority, which is currently in the room. And together we're writing a proposal of how we see the best fit for how to supervise AI. And there's questions about that independence, and they will be solved.
Thank you.
Yes, thank
Great.
you.
I love the fact that you use cybersecurity to justify buying video game PCs.
Thank you.
What's your favorite color of LED lights, and do they make the PC go faster?
Second answer, of course, is yes. And we are, of course, government, so they should be blue. Yeah. Yeah.
Fair, thank you.
Yeah. Other in-depth questions? Yes, behind you.
How do you collaborate with other labs in EU or otherwise?
We are in contact with some other. Well, you have multiple labs. So you have the government labs, but you also have the private labs. I have to say the private labs are always a little bit more difficult to find, but we're actively just saying, hi, how are you doing? Do you have, like for instance, with Microsoft, hi, who is your cybersecurity, and are they doing research, and can we collaborate with that? And we're working together now to work with the other national labs to set up a bigger agreement, because I totally agree that that card you just saw with the topics that we're working on, that should just be shared among all labs so that we don't do the same thing and we can actually ping each other the moment that we're taking the same topic. So I'm working very active on this. We always say we cannot do this alone, it's too big a topic. That's the moment, this is the moment. After this we're going to be black out and you're never going to see us again off the grid. No more questions? Not even from the supervisor? No. Okay. Yeah? Oh yeah, here, one. It's going to be
Yes, thanks. So like I understand it was like a script kiddies, like with all this like a gamer hardware.
Yeah.
Do you also tackle like a state actors?
Yes, so we do look at the state actors, but the state actors generally fall under other supervision tasks.
Okay.
But it's a very interesting question that you ask, because when you're currently being attacked, in the past it's kind of very obvious whether it was a state actor or not, and nowadays this is so ubiquitous you do not know anymore. That's why maybe you saw it very quickly in the other slide. You saw that we work together with our Secret Service exactly for this purpose. And we work very hard with also the Ministry of Defense, and all these parties are now in the same scope suddenly. We always call like the different parts of the pie. So every, just to be fair, every Friday I sit together with those parties and we dedicate a whole day to collaborate on this. Yes? Then I think that's it. Thank you. Yeah.